Hello. So I was given spatial resolution, so I'm going to talk a little bit about that. So spatial resolution is one of the geometric properties. There are two of them. The other one is distortion. Spatial resolution is defined as the accuracy and sharpness of your image. And this is usually determined by your matrix size, pixel size, and grayscale bit depth. So there are a few ways that spatial resolution is measured, and so I'm just going to go through those and talk about a little bit about those. If you see me looking down, I have little notes just to keep me on track. So the first one is spread function, and there's like 3 different spread functions. So there's line, edge, and point, and they all express like the boundaries of the image. So line, it uses narrow slits like on the lead to receive its image, to receive information. And then points, it uses like complex math measurements of the image from a single point. And then edge uses a sharp edge to receive information. The next one will be spatial frequency. So when you have a high spatial resolution, you have high spatial frequency, and this is capable on images of like smaller objects. So yeah, so that really means that your line spaces, like the spacement in a way, like the space in between each of your lines is really close together. Then low spatial resolution has lower spatial frequency. So, and this is usually on images of larger objects. So then this means your lines are farther apart. The next one is MTF, modulation transfer function. And this just measures the accuracy of an image by comparing it to the original image, and it compares it on a scale of 0 to 1. So 0 would mean you don't really have an image or no signal, and then 1, you can't really get a 1. 1 is like you got the image, it's like perfect, but you want to try to aim for 1. The next would be noise. Noise is just the graininess, and usually how noise comes about is if you have insufficient mass, so you don't want that. Now there are a few types of noise. We're not going to really get into that too much, but the 3 types are system, ambient, and quantum. So yeah. Now there's another part of spatial resolution, which is Nyquist criterion. Now this is really when the signal is sampled twice from each cycle. So this is because like you want, how do you say this, you want to like to get all the information, like, because you want your image to look good, so you want like it to be sampled a few times so that you can collect efficient information for your image in a way. So yeah, so that's what you want. Now if your Nyquist criterion is like interrupted or whatever, it doesn't happen, then you have aliasing, which is when you don't sample enough times, you sample less than 2. Now there are a few factors that affect spatial resolution. One of them is your distance, so your SID and OID. You want a larger SID and a smaller OID so you can have great spatial resolution. Then next would be motion. Motion can affect your spatial resolution. So one thing, well, really the main thing to like not have motion is your timing, you know, from your mass, your seconds. That will help with not having a lot of motion. And then next is focal spot. You always want a small focal spot. Small focal spots are always great. That's the best. And this can, like, focal spots goes in with penumbra. It controls penumbra, and penumbra is unsharpened edges. You don't really want penumbra, but umbra is good. Now, the last thing I want to talk about is some ways you can go about, like, solving your spatial resolution. So, like, if you don't have good spatial resolution, some steps you can, like, go about in this certain order. So one, you want to eliminate motion. You have motion, like I just said, that can hinder your spatial resolution. So first thing, check off motion. Is there any motion? Try to eliminate that. And how you eliminate that, you have good communication with the patient and your time. Then next will be reduce your OID, because OID affects it. And OID can even cause a little distortion. We're not going to get into that because we're in spatial resolution. And then you want to reduce focus spot. Like I said, focus spot affects it. You want small focus spot. And then next, increase your SID. So, and just go in that order. And that should help you resolve any problems that you're having with spatial resolution. So, yeah, so thank you for listening. And that's all.